Hello everyone, my name is Carrie, my pronouns are she, her, and welcome back to another episode of my Kerbal Space Program playthrough. In this episode, we will be conquering the moons of Kerbin, starting with a Minmus lander. Although the Mun may be a closer target, we are going to land on Minmus first, because its very low gravity makes it exceptionally easy to land on and take off from. The extra fuel you need to go the further distance in space is nothing compared to the amount that you save by not having to deal with the Mun's higher gravity. Unfortunately, disaster struck between the last episode and this one, and my save file was eaten by the space kraken. Luckily we didn't get very far in the first place, so I've gone ahead and recreated all of those missions very quickly. We went up, collected science, unlocked techs, went more up, to space even, collected more science, unlocked more techs. We flew by the Mun, collected science. This time there was actually a complete eclipse of the Mun by Kerbin, which is pretty neat. We also happened to land in the desert, which gets us an extra biome we didn't have on the first try, although the heat shield was dramatic. Unlocked even more techs, and now we're ready to pick up where we left off last time. So here you see me putting the vessel together, and I want this to be our first craft that actually has multiple crew members. So I'm using this 2-person crew module here. I realized last time I didn't explain the different roles of the crew members for those who may be unfamiliar with Kerbal Space Program. There are 3 different roles that Kerbals can have. They can either be pilots, engineers, or scientists. And all of these have their own distinct purposes. Pilots are most useful in career mode, and correct me if I'm wrong, but I don't believe they serve any particular function in science mode. Engineer Kerbals are good with setting up on-planet science. They can also repair certain broken items with an EVA repair kit. Scientist Kerbals, in my opinion, are the most important, as they are the only ones who can reset experiments that would normally be one-time use. Here you can see I try to make the base of the lander quite wide, as that lowers its center of gravity, and just makes it easier to land properly. I then give us a small booster stage to circularize our orbit, and I have 3 large liquid rocket booster tanks on the bottom, which will get us into our initial suborbital trajectory. Of course, that's assuming that I actually gave it enough fuel. Luckily, that was merely a simulation, which we can use to perfect our design for the actual mission. So naturally, because we ran out of fuel, my first instinct was add more fuel. Makes enough sense. I then realized that this craft is much too heavy to actually make it to orbit. I may have added more fuel, but more fuel means more mass, and I have the same amount of thrust as before, so it doesn't actually get very far before I have to ditch. We quickly perform all the stage separations, and they splash down safely. So I think, alright, we're going to go with a system known as asparagus staging. This way we will start with 5 rocket engines pushing us up, except they have fuel tanks leading into each other. And as our side boosters run out of fuel, we can eject them, expending the dead weight. Of course, even with a perfect rocket design that is very capable of doing the mission, none of that matters if I can't fly it. So here's what happens when you set yourself up for a direct collision course with another celestial body and decide not to slow down in time. Once again, merely a simulation, of course, this was not the real outcome. And now, for the real mission. Here our intrepid adventurers Jebediah, the pilot, and Bob the scientist take off on their way to Minmus. You can see our asparagus staging, as the first stage separates. And you'll notice the fuel tanks burn at different levels because they are feeding into each other. The first stage of boosters feeds into the second, which in turn feeds into the center. Now that we've got ourselves on a decent suborbital trajectory, this tiny stage is going to be used to get us into orbit. So what we're going to do is we're going to burn towards the horizon at our apoapsis until we see a periapsis appear. So in order to be in a stable orbit, our periapsis has to be above 70 kilometers. I make sure to detach this stage of the rocket before we establish a stable orbit, because I don't want to have it just floating around in space forever. Now I circularize the orbit, and I set Minmus as our target. If you imagine that the ellipse that is our orbit were drawn onto a paper, that paper would be our orbital plane. And you'll notice that the orbital plane of Minmus is quite different from the one we're currently on. To fix this, I burn normal at the descending node, or anti-normal at the ascending node. Now I simply mess around with the maneuver nodes until I find somewhere where we can burn prograde to get us on a trajectory to pass by Minmus. So we enter the Minmus sphere of influence. Now we run our experiments from space high over Minmus. I have Bob get out, collect all the experiments, and hop back in. Here I'm just correcting our orbit to be equatorial. While I could certainly land on Minmus successfully without necessarily having an equatorial orbit, I would like one because that's where the best places to land are, in my opinion. Or at the very least, it's easier to come across the best places. Minmus has these very large flat biomes called the flats, and I believe they're supposed to be like salt flats, although made of presumably mint chocolate chip ice cream. While Minmus doesn't have a real-life allegory, unlike the Mun is to the Moon, it is a moon of Kerbin. Of course, there have been many successful missions to the moon of Earth. Although the United States is the only country to have landed humans on the moon, there are 5 that have managed to successfully land probes. Those being in order, the Soviet Union, the United States, China, India, and most recently Japan. Although there have been other countries that have tried. Even though the Soviet Union seemed to be able to land probes on the moon pretty easily, the Russian Federation has yet to successfully land something on the moon. Much like the so-called country of Israel, whose only attempt I have accurately recreated for you here. I guess the moon has a strong aversion to fascism. Maybe we could send up a lunar probe under this administration to test that hypothesis. So now that we've set ourselves up on a nice equatorial orbit of Minmus, you can see the flat regions I'm talking about. See here, I'm going for that big ol' flat area right in the middle. The first thing I do is kill off all of our horizontal speed by burning retrograde. I actually go a little bit overkill and get us going the opposite direction. But now we're on a good line. I deploy the landing legs, and then just start slowing us down. If I tell Jeb to keep the nose of the craft pointed retrograde, he should help us cancel out the angular momentum, while also slowing us down. I'll cut to real time so that you can see the landing. Very satisfying in my opinion. Bob gets out once more and collects the science, and is the first Kerbal to step on another celestial body. I'm sure Bob had something very profound to say, but unfortunately he did not correctly calibrate his OBS settings. While Bob is walking around the minty fresh surface, he remembers he stashed something special aboard the lander that he'd like us to see. Now he's ready to perform his experiment. Take it away, Bob. Impressive. Surely Bob now holds the record for the longest drive in Kerbal history. This in-game experiment is a reference to the real-life incident in which American astronaut Alan Shepard smuggled a 6-iron head onto Apollo 14. He then fashioned himself a club using a tool they already had on board, and hit a couple golf balls on the surface of the moon. I love when the game makes little references to historical events like this. Here I just hide the UI to take some thumbnail screenshots. And Jebediah here, ever the daredevil, does quite the leap to demonstrate the low gravity of Minmus. While the lore in-game seems to suggest that lots of Kerbals think of Minmus as minty, I did see a Reddit post a while ago where they said that they thought of it as a wasabi pea. So what do you think? Let me know in the comments, is Minmus minty or spicy? Now we take off from Minmus quite easily, due to its low gravity, and very quickly get ourselves into a return trajectory to Kerbin. We were actually meant to re-enter the atmosphere on the first orbit, but I ended up time warping a little too fast and the game's physics got confused. Don't worry, we do come back on the second one. So that was quite the successful Minmus mission. Next we go to the other moon of Kerbin, the Mun, a much more direct analog of our own moon. And we've got ourselves a pretty nice haul of science points. Naturally we go to the tech tree and unlock some different rocket parts and science experiments. And then I go to the tracking station and clear up all the debris from the other stages that separated. Unlike the last lander, we're going to be doing this one Apollo style. So what exactly do I mean by that? For those unfamiliar, the Apollo program utilized a setup with 2 docked craft. One craft was the Command and Service Module, or CSM for short. One astronaut would stay in the CSM in lunar orbit, while the other 2 crew members took the second craft, the Lunar Module, and descended, landed, did their lunar excursions, and returned to orbit. The 2 craft would then dock in orbit and return to Earth. Of course, most famously, this system was used by Apollo 11, the first mission to land humans on the moon. Truly an incredible feat of engineering, perseverance, and human ingenuity. And yes, it really happened. If anyone wants to argue this point, I know where you live, and Buzz Aldrin will be paying you a visit.
You're a coward and a liar and a thief.
Besides, even if they did want to fake it, I doubt NASA could have done it perfect enough for Stanley Kubrick. With the technology they had in 1969, it was easier to just actually land on the moon than to fake landing on the moon. While this mission won't go quite the same as the Apollo, I still call it Apollo style because we're doing a separate landing craft and orbiting craft. This craft is also the first time I actually encase it in a fairing. The idea behind this is it completely covers up our payload so that we don't have to worry about the payload itself being aerodynamic. Once we get to the upper atmosphere or space, we end up ditching this thing. Of course, those of you paying very close attention may have noticed that I actually forgot to put a heat shield and decoupler onto the last stage of this. And here's what happens when you do that. Heat shields are so important not only because they protect those in the cabin from excessive heat on re-entry, as the name implies, but it also provides a blunt face that helps slow down the capsule with air resistance. I was too embarrassed to even let it hit the ocean. I knew what was going to happen. The stages that will lift Gemini 1 into orbit are much the same as those that we used for the Exodus 2. I decided to call it the Gemini 1 because, Gemini, twins, 2 craft. I thought it sounded neat. Of course, you all have seen me get to orbit enough now by this point in the series. A key difference here from all of our previous rockets is when we get into orbit, we actually separate the 2 craft and dock them for how they will be until they get to the Mun. We then do our translunar insertion burn. While I would recommend you set up maneuver nodes for this, I decided to do it the classic way that Scott Manley taught me years ago, which is just start burning prograde whenever you see it come over the horizon. I then just tap the throttle ever so slightly to get us on a very low periapsis. Since we've already collected science from space high above and near to the Mun on our previous missions, we won't have to do it this time. While the Mun doesn't have quite the low gravity that Minmus has, it is of course much lower than Kerbin. Here I have Bill the engineer and Bob the scientist get out and get into the Lunar module, or rather, Munner module. Valentina on the other hand stays in the command and service module, much like the Apollo, orbiting the Mun. Initially we're aiming just a little bit too close to the lip of this crater, so I angle us off to the side a little bit. While it does seem a little sketchy to land on a surface this steep, I'll slow it down and let you see it take place. Another very successful landing. I had to pause the game and go run some errands, so when I came back and loaded the save, our craft just started kind of sliding. Kerbal does this weird physics thing sometimes, where whenever you reload the game, it thinks that everything has to be moving again. Eventually it did settle down. Of course, Bob collects all the science again from the surface. It is on this mission that we actually get to use our deployable science experiments. So we set up a little experiment control station, a little solar panel generator, and a little goo monitor. And I speed up time here so that we can let the science on surface transmit for a few days. It doesn't get you a whole bunch, but it is there, and it takes some time to build up. Then it's time for us to return back home. So I'm now going to attempt our first docking of the series. I start by getting us into an orbit around the Mun. I set the command and service module as the target, and try to get us on the same orbital plane. Since we are currently behind the CSM, I decide to put us in a lower orbit than it is in, because lower orbits are faster. This way we will catch up to it over time. So we get pretty close to it. As we approach, I start killing off our relative speed by burning retrograde not in reference to our orbit, but in reference to our target. This way we have no sideways velocity relative to each other, or at least as little as we can do. The easiest way I've found to dock 2 craft in this game is the lazy method, as Matt Lown calls it, where you simply set the docking port of the other craft as your target, and have your pilot point the craft that they're piloting at that target. If you do this on both craft, then they will just automatically be looking at each other. So then we can just ever so slightly hit the throttle, and we will very gently drift together. We then gather all of the science out of the Munner module, put it into the CSM, get Bill and Bob into the CSM, where they are reunited with Valentina, finally, after days on the Munner surface, and they're ready to come back home. Here, Bob wants to show us a little EVA experiment again. While floating in space, he pulls out a giant wing nut to demonstrate the Zhanabekov effect. Named after Soviet cosmonaut Vladimir Zhanabekov, this phenomenon demonstrates how an object can flip itself when rotating around its intermediate axis. You can recreate this effect on Earth using other methods, but it's much more dramatic in this microgravity environment. Another successful mission. Flags were planted, biomes were explored, and I hope you'll join me next time as we attempt our first interplanetary excursion. And actually, the first time I have ever tried to do it in the game. This is as far as I've ever gotten playing alone. So go ahead and click the like button if you liked the video, hit subscribe if you want to see more, or I will put you on our next rocket with no heat shield. Your choice.